At roughly 5 o'clock on the morning of September 24, 1999, the ground beneath a 2,000-ton Marion 7820 dragline gave way, sending the machine more than 50 feet into the Pennsylvania quarry it was digging and rolling it completely upside down. This was a dragline with a 93-meter boom and a bucket capable of moving roughly 42 cubic yards in a single bite, the primary machine stripping the earth away from the limestone below. And 2 men were inside it when it went over. The Marion had been performing one of the most ordinary movements in its entire working life, swinging a loaded bucket toward its dumping point. Then the bench supporting thousands of tons of machine stopped holding. Both crew members survived and were hospitalized, but the dragline did not come away lightly. Its machinery house, mast, and large sections of its boom were wrecked, leaving the quarry with its main stripping machine lying inverted at the bottom of its own excavation. And that created another problem immediately. The cement operation still needed limestone. The overburden above it still had to move, but its biggest machine couldn't move at all. There was an older Marion 7400 nearby, a much smaller dragline the company had reportedly been preparing to sell. Suddenly, that outdated machine was the one keeping the stripping operation alive. The wrecked 7820 looked like scrap. Management could replace it, abandon it, or attempt something far stranger, somehow turn 2,000 tons upright and rebuild it. 17 months later, that same dragline would dig again. The question was what it took to get there. If you enjoy these documentaries, then subscribe. Thank you. Now back to the gritty history. What it took starts with a problem nobody on that site had ever solved before. How do you take something that heavy, lying upside down in a hole, and put it back on its feet? No crane at Wampam, and no crane most companies would ever own, was rated anywhere near 2,000 tons. Whatever solved this wasn't going to look like a normal lift, and we will walk through exactly what it did look like, with the numbers in order, later. There is also a dollar figure attached to this story, filed in federal court years afterward, north of $12 million, and it drags in 4 separate companies who spent years arguing over who was actually responsible for that bench giving way. One of the 2 men who rode the machine down has a name in that court record, David Carcase, and what happened to him after the accident is a thread this account is not going to rush or invent. Even the 50 feet in that first sentence is not the whole picture. One source puts the fall at 50 feet. Another, filed under oath, puts it closer to 70. We will sit with that gap properly when we get there. First, the size of what actually went over that edge. 2,000 tons. Say the number once and it means nothing. Most people have no working sense of what 2,000 tons of anything looks like, let alone 2,000 tons of engineered steel standing on legs. Put it a different way, that's the rough equivalent of 1,300 pickup trucks stacked into one connected machine, balanced on a set of shoes instead of wheels, and asked to swing a bucket the size of a small house back and forth across a quarry bench for years without complaint. It did that at Wampam for 5 years before the ground stopped agreeing to hold it. And then, on one ordinary morning in September of 1999, it went over. Completely over, machinery house down, boom folded, the whole hull inverted at the bottom of the pit it had spent 5 years digging. The men called it Brutus. The name shows up in the wreck photographs and in the captions written by the people who worked around it. It stuck to the machine long before anybody imagined it ending up on its back, not something dreamed up in an office for a press release. We'll come back to why a name like that attaches to a piece of industrial equipment, and what it says about the men who spent their shifts inside it. It was one of the larger walking draglines operating anywhere in that part of Pennsylvania, and for 5 years, on a bench that had held every single time before, it never so much as slipped. It did not tip. It did not stumble. Then it went over. The men who eventually solved the problem of putting it back on its feet didn't reach for bigger iron. They reached for 8 ordinary scrapers, machines built to push and haul dirt around a job site, and over a mile of wire cable, and they built a system of pulleys anchored 400 feet from the wreck that converted the horizontal pulling power of 8 tractors into a slow, grinding rotational force, strong enough to roll the hull back onto its feet. That system gets its own telling later, with the numbers in order: rope diameter, sheave count, the exact distance those anchor blocks sat from the machine. For now, hold the shape of the idea: dirt-moving machines, repurposed as a giant winch, rolling 2,000 tons of dead steel like a turtle being flipped by hand. A claim for damages in excess of $12 million filed in federal court against the contractor who had put the machine back together 5 years earlier, more than 500 miles away, when it was moved from a coal operation in Kentucky to this limestone quarry in western Pennsylvania, is the other figure worth keeping in your pocket. That claim opens up a legal fight involving 4 separate parties, none of whom agreed on who was actually responsible for a bench of solid ground, failing at 5 in the morning. We're going to walk through that fight in full later, with the actual allegations each side made, because it's one of the more tangled aftermaths you'll find attached to an industrial accident of this size, and because pretending there's a single clean villain in this story would misstate the record. There isn't one. There's a physical event everyone agrees happened, and years of disagreement about why. David J. Carcase is the name the federal court record gives us, an employee of Minserco Incorporated, the contractor operating the dragline under contract for the quarry's owner that morning. He was inside Brutus when the bench gave way. He survived it, and he later sued. We're going to give him a proper place in this story. Everything that follows, the recovery, the 17 months, the machine going back to work, happened around a real event that put a real man inside 2,000 tons of falling steel. The record doesn't give us his words. It doesn't give us a transcript of what he said when the ground moved. What it gives us instead is a timeline, a set of engineering numbers, and a legal filing, and that's what we're going to build this account from, piece by verified piece, starting with the machine itself, how it was built, how it got to Wampam, and exactly what it was fighting against every single day it worked that quarry. The Marion Power Shovel Company built walking draglines for most of the 20th century, out of Marion, Ohio, and by the time Brutus rolled off whatever combination of rail cars and flatbeds carried its components across the country, the company had a long history of building machines that don't get smaller with each generation. They get bigger, because the jobs keep demanding more overburden moved per shift, more limestone or coal exposed per dollar spent running the thing. This particular 7820 didn't start its working life in Pennsylvania. It came from a coal operation in Kentucky, where it had already put in years of service stripping ground away from coal seams before Southdown's cement operation in Wampam needed a machine of its size and arranged to have it moved. Moving a machine like this is not a matter of driving it down a highway. A walking dragline this large doesn't travel on trucks. It barely travels at all, even under its own power, and getting one from an active Kentucky coal site to a limestone quarry in Lawrence County, Pennsylvania, meant taking it apart, piece by piece, trucking or railing the components to Wampam, and rebuilding it entirely on-site from the ground up. The company brought in for that job was Industrial Contracting and Erecting Incorporated, ICE, in the shorthand the trade press uses, and the erection process took roughly 8 months from the first piece arriving to the finished machine standing complete. 8 months of cranes, welders, and riggers assembling the machine piece by piece, boom section by boom section, before it ever moved a single cubic yard of Pennsylvania ground. Brutus began work at Wampam in the middle of 1994, 5 years and change before the morning it went into the pit. What it existed to do was simple to state and brutal to execute: pull the overburden off the limestone. Underneath a working quarry bed, there's a layer of rock and earth that has nothing to do with the material a cement plant actually wants. Dozens of meters of it, sitting on top of the limestone like a lid, and somebody has to take that lid off before a single truckload of usable stone can come out of the ground. That's the job a dragline this size is built for. It doesn't drill, it doesn't blast, though blasting often loosens the ground ahead of it. It swings a bucket out over open ground, drags that bucket back through loosened rock and earth with the full weight of the machine behind the pull, hoists the load, swings it around, and drops it somewhere it won't be in the way. Then it does it again. And again, thousands of times a week, for years, at a scale that makes the individual cycle almost boring to describe and the cumulative total almost impossible to picture. A boom, 93 meters long, a bucket rated at 32 cubic meters, roughly 42 cubic yards in the units the operators actually used, moving that volume of rock and dirt on every single pass. The overburden itself is the antagonist of this story, though it doesn't announce itself that way. It just sits there, layer on layer, indifferent to the machine working on top of it, until the machine's own weight and the changes the machine makes to the ground around it by digging that ground away start interacting with each other in ways that aren't always predictable from a drawing. A quarry bench is engineered ground. Somebody calculates how steep it can be, how close a machine that heavy can safely work to its edge, how much material can be removed before the remaining slope loses the strength to hold what's still standing on it. Those calculations hold, generally, for years at a time, across thousands of cycles, until, on one particular morning, in one particular spot, they don't. That $12 million figure we mentioned earlier belongs to the aftermath of exactly this kind of failure. It's the amount Cemex, the company that had by then taken over Southdowns operations, alleged in a lawsuit against ICE, the same contractor that had disassembled, moved, and rebuilt Brutus back in 1994. Cemex's claim, laid out in a federal court filing, argued that ICE had performed that original reassembly in a careless, reckless, and negligent manner, and that the failure 5 years later traced back to that work. We won't resolve that claim here because the sources don't resolve it either. It stayed contested for years, tangled up with at least 3 other parties making their own competing claims about where the fault actually lay. What matters for now is the shape of the accusation. A 5-year-old rebuild, blamed for a collapse in 1999, with 8 figures attached to the alleged damages. Keep that number in your pocket. We're coming back to the full fight later, once you understand what could go wrong with a machine like this, mechanically, in the first place. A walking dragline has a strange relationship with the ground beneath it, and that strangeness is what made a bench giving way even possible. A crawler excavator moves on tracks, the way a bulldozer or a tank does, metal treads gripping the ground, distributing weight, letting the machine crawl forward a few feet at a time under continuous power. A walking dragline doesn't do that. It has no tracks at all. Instead, a machine like Brutus sits on a circular base plate, called a tub, and mounted to that tub are enormous mechanical feet, sometimes called shoes or pontoons, that lift the entire machine's tub clear off the ground, shuffle it forward a stride, and set it back down, walking, in the most literal sense the word can carry, one lumbering step at a time, at a pace measured in feet per minute rather than miles per hour. Watch it from a distance and the whole superstructure seems to breathe, lift, shuffle, settle, lift again, closer to the gait of some enormous mechanical animal than anything else you'd find on a construction site. It's an odd, almost prehistoric motion to watch, a 2,000-ton machine rocking itself forward on mechanical feet instead of rolling, and it exists because tracks that could bear this kind of weight and still swivel and steer would be far heavier, far more expensive, and far less stable than a walking mechanism built to distribute an enormous static load across the widest possible footprint whenever the machine is actually working. That's the key word, footprint. When Brutus wasn't walking, it was sitting, its full 2,000 tons resting on that circular tub, planted on whatever ground the quarry crew had prepared for it, and that ground had to hold the machine's entire weight, while it simultaneously swung a loaded bucket, rock and earth adding still more tons to the load, out over the excavation and back again, cycle after cycle, hour after hour. The boom did the reaching, cables did the work at the business end, a hoist cable to lift the bucket, a drag cable to haul it back through the material being cut, both running the length of that 93-meter boom on wire rope, engineered to survive tens of thousands of load cycles without failing. You don't buy that kind of cable off a hardware store shelf. It's measured in tens of millimeters of diameter, inspected, retired, and replaced on a schedule because a snapped hoist cable on a loaded bucket is its own category of disaster. None of that cable, though, is the part of the machine that failed on September 24, 1999. What failed was underneath it, the ground itself, the bench the whole 2,000-ton assembly was standing on while it swung a loaded bucket toward its dumping point. There's a trap built into this kind of operation, one that never shows up if you only look at the machine and not the ground it's sitting on. A stripping dragline works at the edge of an excavation almost by definition. It has to because the material it's removing is right there, at the boundary between untouched ground and the pit that's already been dug. That means the machine is constantly operating close to a slope it, or the equipment working alongside it, has recently cut. The bench supporting the machine is engineered ground, not natural, undisturbed ground that sat unbothered for centuries, freshly exposed, holding a slope angle somebody calculated as safe based on the material's properties. But rock and earth don't always behave the way calculations predict, especially not after being blasted, excavated, and left to sit through weather and vibration and the repeated hammer of a 2,000-ton machine walking and working across it, week after week. Every stripping dragline that has ever worked a quarry or a coal pit has spent its working life standing on ground it, in some sense, helped destabilize simply by being there and by removing the material around it. The dragline's own stability, in other words, depended entirely on ground that the mining operation was simultaneously undermining, a condition baked into the fundamental geometry of stripping work with a machine this size, true at Wampam and true anywhere draglines this large work a bench. It's why bench stability is one of the things quarry engineers watch obsessively, checking slope angles, checking for cracks or seepage or subtle ground movement, trying to catch the signs of a bench losing its margin before that margin runs out completely. Most of the time, the system works. The bench holds, the machine walks forward as material gets removed, the whole operation advances a few feet at a time across a quarry face for years without incident. Which is exactly what happened at Wampam for 5 years, from the middle of 1994 until the last week of September 1999. One account of what actually triggered the failure, a lower confidence source, a mining equipment site that catalogued photographs of the wreck under the caption, "Brutus dragline flipped over," describes the mechanism this way. The dragline slid off the high wall and flipped into the pit, and one of its own walking shoes dug into the ground during that slide, catching hold and starting the rollover rather than letting the machine simply slide flat. If that account is accurate, it means the very mechanism that let Brutus move, those enormous mechanical feet, planted and lifted and planted again, became the pivot point that turned a slide into a complete inversion. A machine sliding downhill is a bad morning. A machine sliding downhill and then catching a foot and rotating end over end is the difference between damage and total loss. We're not going to treat that account as settled fact, because it isn't corroborated the way the trade press coverage of the accident's basic outcome is corroborated. What is documented, cleanly and consistently, is the routine framing of the maneuver itself. The trade press describes the bench giving way while the machine was swinging a loaded bucket toward its dumping point. The single most ordinary motion a stripping dragline performs, repeated thousands of times a week for 5 years on that same quarry face. That's the detail that makes this story land differently than a story about an operator error or a machine pushed past its rated limits. Nobody was doing anything unusual. The machine was doing exactly what it had done every working day since the middle of 1994, on a bench that had held every single time before this one. Whatever the precise mechanical trigger, the outcome converts the machine's greatest asset, its sheer static mass, planted and swinging with total confidence, into its greatest liability the instant the ground beneath it stops agreeing to hold that mass. 2,000 tons resting on solid rock is one of the most stable configurations you can put on a job site. 2,000 tons resting on ground that has quietly lost its margin is something closer to a 2,000-ton pendulum waiting for the first excuse to swing. The legal fight that followed would spend years arguing about whose responsibility it was to know the difference before that morning arrived. We'll get to every piece of that fight. First, though, meet the men who actually rode this machine to work every day at Wampam. Real people, showing up for another ordinary shift, riding inside 2,000 tons of steel that was about to fail. Daily life aboard a machine like Brutus barely survives in the sources, and it's better to say so than invent texture they don't support. There's no surviving shift log, no interview with the crew describing what a typical day running this dragline felt like, no quoted recollection of coffee breaks or radio chatter or the particular sound the machine made when the bucket bit into rock. What exists is a name, a role, and a timeline, and from those three things, a real picture still comes into focus. The name is Brutus. It shows up consistently enough, across enough period photographs and captions of the machine at this quarry, that it wasn't a passing joke. It was what the people who worked around this dragline actually called it, the way heavy equipment across 100 years of industrial history has picked up names that have nothing to do with a manufacturer's model number. There's a pattern to which machines get that treatment and which don't. Nobody names a forklift. Nobody names a delivery van. The machines that earn names tend to be the ones that dominate a job site by sheer physical presence. The ones a crew has to build their entire working day around. The ones that can kill a man in an instant of inattention and that, day after day, don't. Calling a 2,000-ton dragline Brutus is respect with teeth in it, the kind of name you give something you've decided to treat as a personality precisely because treating it as just a machine would mean forgetting how much power is sitting under that boom. I've stood next to a dragline bucket that size. Photographs don't get the scale right. You don't understand what 42 cubic yards means until you're standing next to the bucket and realizing you could park a car inside it with room to spare. The role belongs to David J. Carcase. He was an employee of Mincerco Incorporated, the contractor operating Brutus under contract for the quarry, and on the morning of September 24, 1999, he was working inside the dragline's cab, the operator house, the enclosed compartment mounted high on the machine's rotating deck, where the controls for the boom, the hoist, the drag, and the swing all come together under one roof. That's the job. Whoever sits in that cab is the one actually running the machine, moment to moment, translating a stripping plan into thousands of individual cycles of dig, hoist, swing, dump, and swing back. It's a job that requires sitting, physically, at the exact point on the machine that's farthest from the ground and highest off whatever bench the machine happens to be standing on that day. Which means it's also the job that puts a person in the most exposed position if that bench fails. There was a second crew member in that cab as well, alongside Carcase. The sources don't give us his name, and rather than invent one, a second man was present, injured along with Carcase, and hospitalized along with Carcase, and beyond those bare facts, the documentation doesn't go further. 2 men, 1 cab, 1 machine standing on a bench that had held every single day since the middle of 1994. Picture the shift the way the facts actually allow, without dressing it up with details nobody recorded. 5 o'clock in the morning is early enough that a quarry operation runs on artificial light rather than daylight. Early enough that the crew coming on shift has done this exact sequence of motions so many times it doesn't require conscious thought anymore. Climb up into the cab, run the pre-operation checks, bring the machine's systems up, and begin the cycle. Reach the boom out over the bench, drop the bucket, drag it back through the loosened overburden, feeling the resistance build through the cable and the deck underfoot as the load builds. Hoist. Swing the loaded bucket around toward the dump point, the machine's own mass shifting to counter the swinging weight of rock and cable, the whole 2,000-ton hull leaning almost imperceptibly into the turn the way it had leaned into that exact turn thousands of times before. Nothing in the sources suggests this particular swing looked, sounded, or felt any different from the one before it, or the one before that, which is exactly the detail that matters here. The bench had held for 5 years of these swings. It was about to stop holding on this one, and nobody in that cab had reason to expect it. That ordinariness is the whole point, worth sitting with before the ground actually gives way. Everything that follows happens during the single most routine motion this machine performed. On a bench that had proven itself reliable for 5 straight years, at an hour when the crew's attention was locked into a rhythm built entirely on that reliability holding one more time. It didn't. At approximately 5 o'clock in the morning on September 24, 1999, with Brutus mid-swing, a loaded bucket somewhere out over open ground on its way toward the dump point, the bench supporting the machine gave way. There's no dramatic buildup in the sources, no warning tremor, no crack widening for minutes before the failure, nothing documented as advance notice. What the trade press describes is the outcome. The ground beneath the machine failed while it was performing a normal stripping operation, and the 2,000-ton dragline went down. One account of the physical sequence, again the lower confidence source cataloging the wreck photographs, holds that the machine slid off the high wall first and that one of its walking shoes caught the ground during that slide and turned a slide into a roll. However it began, the end state isn't in dispute. Brutus went over the edge and fell into its own pit and landed completely upside down. The machinery house that had sat on top of the deck now underneath it, the boom that had reached 93 meters out over the quarry, folded and crushed into the ground, the whole hull inverted at the bottom of an excavation it had spent 5 years creating. For the men who reached the rim of that pit in the hour afterward, the site itself would have been almost unrecognizable as the machine they had worked around for 5 years, a shape built to tower over the quarry now folded into it, its silhouette wrong in every direction at once. 2 men rode that fall down. Carcase was one of them. The unnamed second crew member was the other. Both were injured in the fall. Both were hospitalized afterward. The available sources don't specify what those injuries were, and it's better to resist the temptation to fill that gap with invented detail. What's clear is that 2 human beings were inside a 2,000-ton machine when it rolled completely upside down into a rock quarry, and both of them lived to be carried out of that cab and taken to a hospital. That fact alone tells you something about how the cab itself was built, reinforced enough, structured enough, that a complete inversion from height didn't kill the 2 men riding it down. How far down exactly is a question the sources themselves can't agree on, and the honest move here is to say so rather than pick whichever number sounds more dramatic. Cranes Today magazine, covering the recovery afterward in the trade press, describes a fall of more than 15 meters, in round numbers, roughly 50 feet. The federal court record, in the negligence suit Carcase later filed, describes the machine going down an approximately 70-foot embankment. 50 feet, 70 feet. Those aren't rounding errors that happen to land on different sides of the same number. They're a 20-foot gap in the documented height of the fall, coming from 2 different kinds of sources that had 2 different reasons to measure it. A trade publication reporting on an engineering recovery and a federal court record built around a personal injury claim. Neither source is obviously more reliable than the other, and nothing in the material resolves the discrepancy. What both sources agree on, without exception, is the outcome. A machine that size, falling that kind of distance, landing completely inverted, with 2 men inside it who survived. What was left at the bottom of that pit in the hours after the collapse looked from every reasonable angle like a total loss. The machinery house, the entire operator cab and control structure, was destroyed in the fall, along with the mast that had held the machine's rigging aloft. Significant sections of the boom were crushed or twisted beyond repair. A 2,000-ton excavator, sitting completely upside down at the base of the excavation it had been actively working, is the kind of wreck that gets photographed, assessed, and, in a great many cases across heavy industry, written off entirely in favor of ordering a replacement, because the cost and risk of attempting a recovery this large can easily exceed the cost of starting over. And underneath that physical wreckage, a second kind of collapse was already beginning. A legal one, spreading outward from the pit in every direction almost as fast as news of the accident itself. Carcase, once his condition allowed it, brought a negligence lawsuit against Cemex, Incorporated, the company that by then owned the quarry operation. Cemex, separately, filed its own lawsuit, a property and business damages claim aimed at Industrial Contracting and Erecting, Incorporated, the contractor that had disassembled, transported, and reassembled Brutus 5 years earlier when it moved from Kentucky to Wampam. Cemex's complaint alleged that ICE had performed that original reassembly work in a careless, reckless, and negligent manner, and it put a number on the damages it believed that alleged negligence had caused, in excess of $12 million, covering property loss and business damages tied to the collapse. That figure is a direct quotation from the legal filing, an allegation made in a lawsuit, not a proven fact, not a verdict, not a figure any court is on record as having awarded. ICE didn't simply defend against that claim. It filed a third-party action of its own against Minserco Incorporated, Carcase's employer, the company that had been operating the dragline under contract at the time of the collapse, alleging that Minserco's own negligence had contributed to the failure. That claim ran straight into a wall built into Pennsylvania law. Under the state's Workers' Compensation Act, Minserco was immune from direct liability to its own employee, Carcase, for his injuries, even while it could still be pulled into the broader property damage fight as a third-party defendant answering to ICE's allegations. A federal magistrate judge, reviewing the tangle of overlapping claims, denied a motion to consolidate Carcase's personal injury case with the Cemex versus ICE property damage case into a single proceeding, citing exactly that immunity complication alongside a straightforward concern about confusing a jury with two very different kinds of claims running through the same courtroom at once. Sit with the shape of that fight for a moment, because it's a genuinely tangled one, and pretending otherwise would misrepresent the record. Carcase, the man who was actually in the cab, sued the quarry's owner. The quarry's owner sued the contractor who had rebuilt the machine half a decade earlier, alleging carelessness serious enough to justify a claim above $12 million. That contractor turned around and blamed the company operating the machine day to day. And the company operating the machine, protected by workers' compensation law from Carcase's own claim, still found itself dragged into the property fight anyway, as a third party answering somebody else's allegation. 4 parties, 2 separate lawsuits that a judge specifically declined to merge into one. Nowhere in the material available is there a clean, single, agreed-upon answer to the question of who actually caused the bench to fail. And the honest way to leave that thread is exactly the way the record leaves it. Contested, spread across competing allegations, resolved for none of the parties in any documented final judgment. Carcase's own through line ends exactly where the documentation runs out. He was in the cab, he was injured, he was hospitalized, he survived, and he sued. What happened to that lawsuit after it was filed? Settlement, verdict, dismissal, any final resolution at all, isn't something the sources confirm, and rather than manufacture a tidy ending for a real person's real legal claim, the plain thing to do is say so directly. Somewhere in a Pennsylvania courthouse, a case with David J. Carcase's name on it moved through a system that simply doesn't tell us how it came out. That's not a satisfying place to leave a man's story. It's the true one. What the record does tell us, in full, is what happened to the machine, and to the quarry that suddenly needed to run without it. With Brutus destroyed or looking destroyed, the Wampam quarry still had a cement plant downstream that needed limestone every day, and a stripping operation that had just lost its primary machine overnight. That's where the older dragline comes back into the story. The Marion 7400, a smaller machine with a 14 cubic yard bucket, the one the company had reportedly been close to selling before the accident happened. Instead of leaving the site, that older machine got put back to full-time work, carrying the entire stripping load the 7820 had been handling, for the better part of the 17 months it would take to get Brutus running again. Jim Houck, the quarry manager, put it plainly to the trade press afterward. "We won't be selling that machine for some time yet. It really saved the day during our ordeal." A machine the company had nearly let go became, almost overnight, the only thing standing between the quarry and a production shutdown. The bigger decision, though, belonged to management, and it wasn't obvious which way it would go. A 2,000-ton machine, completely inverted, with its operator house and mast destroyed and significant sections of its boom crushed, is exactly the kind of wreck that gets scrapped rather than rebuilt in a great many cases across heavy industry. The math on a full replacement often looks cleaner than the math on an uncertain recovery. Here, after assessing the wreck, management chose the recovery. Mincerco's engineers were the ones who designed how it would actually happen, and the plan they came up with is one of the more remarkable pieces of applied heavy equipment engineering in this whole account. The first steps were the unglamorous ones. Crews excavated around the fallen machine to get physical access to it, clearing enough ground around the inverted hull to bring rigging and equipment in close. The boom, already crushed and twisted from the fall, was removed entirely, simplifying the shape of what needed to be rolled and getting a dangerously unstable structure off the machine before anyone tried to move the hull itself. Then came the rigging, a system attached directly to the 2,000-ton hull designed to convert a pulling force into a rotational one, strong enough to walk that inverted mass back over onto its feet. The pulling power itself didn't come from anything built for this purpose. It came from 8 motor scrapers, Caterpillar 627 and 637 models, machines whose entire design purpose is pushing and hauling loose earth around a job site, not rolling fallen excavators upright. Those 8 scrapers were connected to the Dragline's hull through roughly 2,130 meters of wire rope, about 1 1/3 miles of cable, 50 millimeters in diameter, threaded through 7 separate sheave support assemblies and 2 multiple sheave block assemblies positioned roughly 122 meters, about 400 feet, away from the machine. Picture that geometry for a second. 8 tractors, arranged to pull in a coordinated line, their combined horizontal tractive force routed through more than a mile of cable, and a network of pulleys spread across a 400-foot working radius, all of it converging on a single 2,000-ton object lying on its back. And every foot of that cable, every sheave in that chain, existing for exactly one purpose: to turn 8 machines' worth of straight-line pulling power into a slow, controlled arc of rotation. When the crews finally engaged that system and the scrapers began to pull, the motion was a grinding, incremental roll, inches at a time, nothing like the sudden violence of a demolition or a collapse. The accumulated tension of over a mile of 50-millimeter cable translated into rotational force at the pivot point of the hull, the whole assembly of tractors and pulleys and steel working in concert to do something none of those individual machines had ever been built to do. 2,000 tons of dead steel, completely upside down, began to turn. It took the combined output of 8 ordinary earth-moving machines, rigged as a single system, to accomplish what no crane on that job site could have done alone. And slowly, the hull that had landed inverted came back over, settling, eventually, back onto the base it had been designed to stand on in the first place. Getting it upright was only part of the job. 2 Manitowoc crawler cranes, a Model 4100 and a Model 888, each rated at 208 tons of capacity, moved in afterward to handle the re-erection work the rollback rig couldn't do on its own, lifting components back into position, helping rebuild the structure piece by piece. For those weeks, the site looked less like a repair yard than a shipyard mid-build. Crews welding a machinery house back together plate by plate, a mast climbing again where the original had been crushed flat into the pit floor, the whole yard smelling of cut steel and diesel exhaust for the better part of a year. The machinery house, the entire cab and control structure destroyed in the original fall, had to be reconstructed completely, built again essentially from scratch. The mast went through the same process. Some sections of the original boom were salvageable and went back onto the machine. A great deal of it wasn't, and had to be replaced outright, new steel standing in for what the fall had destroyed. And then, once the machine could stand, and once its walking mechanism had been restored to working order, Brutus did something that reads almost like a small act of defiance. It walked. Under its own mechanism, powered by a portable generator rather than the machine's normal systems, the rebuilt dragline shuffled roughly 2.4 kilometers, about a mile and a half, cross-country, from the site where it had been recovered and partially rebuilt to the repair site where the remaining work would finish. Picture that image plainly. A machine that had been lying dead and inverted at the bottom of a quarry, generator-powered, walking itself across open ground on the same mechanical feet that, by one account, had helped roll it over in the first place. The whole process, start to finish, from the morning the ground gave way in September of 1999 to the day the rebuilt machine returned to active work, took approximately 17 months. Brutus went back to work on February 26, 2001. Jim Houck, the same quarry manager who'd praised the old 7400 for saving the operation during the crisis, had a different verdict once the rebuilt 7820 was back on the job. We now have a dragline that's better than the one we had before. We were very impressed with the work done by Mincerco. That reads like a working quarry manager's plain assessment, not a line written for a press release by someone who never saw the machine, delivered after 17 months of watching a 2,000-ton wreck get taken apart, rolled upright, and rebuilt into something he judged an improvement on the original. A machine fell more than 50 feet, or by the court's own account closer to 70, into the pit it had spent 5 years digging, and landed completely upside down with 2 men riding it down. It went back to work.